Hi everyone, this will be a mathematical demonstration of a position, velocity, and acceleration vector. I looked at this simple example you might have seen in the chapter 9 of parametric equations. So this is cosine t and sine 2t in two-dimensional space. So let's interpret that as a position vector after t seconds. So if you look at this movie, kind of shows you how this particle is moving around this path, and that's what that is, and it continues where it started from. You can clearly see when it slows down, when it turns around, that curvature right there kind of slows down whenever it's a more straighter path, and then it speeds up, and even there it just speeds up like this. So that shows the motion of the particle. What we have learned is analyzing this motion with the velocity and acceleration vector. So this is that. So if you look at this picture here, the position is at the t equals 0 is this position, and this red vector is showing the velocity direction at that instantaneously. That particle is trying to moving toward to that direction, and what this blue vector is saying, this is a second derivative, is telling you in the next moment it's gonna turn to the left a little bit with this much of a kind of force. And it's if the velocity, the magnitude of the velocity is changing, it's not easy to interpret exactly what this vector is going to do to that, but it at least tells you that it's going to turn to the left as we go move on. So as you can see, the vector is going to turn left, and then this acceleration vector is constantly changing. It's not always the same direction or same magnitude. So as you can see, as you go to that at the top, like we have noticed before, the length of this vector is very small, so the speed of this vector is very small, and there's this large acceleration is acting on that moment to make it turn, and at that point the direction of the acceleration and velocity is kind of pointing the same direction, though, so the acceleration exerted, the force that is exerted to that direction is greater, so it's going to pick up the speed, getting faster and faster, but at the same time the acceleration got smaller, so it's kind of tricky motion that is involved in there, and then it changes acceleration and changes direction that's acted on that. It's pointing other directions, so it is not really the acceleration it's kind of acceleration that's exerted to that direction that makes this change of this velocity vector going toward to that and moving out like this. Alright, what you are seeing on the right is because you're seeing on the path that you kind of see what's happening, but if you kind of pretend that you don't see where the path is and think about how this velocity and acceleration vectors are related, so here, not knowing where this thing is going, so we parallel transported everything to this position. So we have this velocity vector, and then acceleration vector is exerted to that direction, so it's going to turn to the left as time passes, as you can see, and then acceleration vector is pulling toward the downward, so the velocity vector is going to turn more and almost lost the magnitude almost down to 0, and so on. So this is a kind of parallel transported picture. But that's what we are really calculating when you're calculating that, and Newton thought this is exactly the pointing where the source is, and the magnitude of the vector is really the magnitude of the force that is exerted acting on that position. Thanks.